Welcome to this explainer. Today we're zooming in on a silent crisis in our food supply and the absolutely fascinating technology that's stepping up to solve it. We're talking about something that affects every single one of us, even if you've never set foot on a farm. We're talking about the food on our plates, the stability of global agriculture, and a technological revolution that sounds completely like science fiction, but is actually happening right now in fields all across the world.
All right, let's kick things off with a pretty shocking statistic: 20 to 40%. I want you to really think about the scale of that for a second. This represents the staggering amount of global crop production that is completely destroyed by plant diseases every single year. Just imagine if, say, a third of all the factories in the world suddenly stop producing goods. Well, that's the reality agriculture faces annually. It's this massive, silent epidemic wiping out billions of dollars and millions of tons of food.
And you know what the craziest part is? This immense loss isn't happening due to a lack of hard work by farmers. It's not because the technology to treat the crops doesn't exist either. It happens simply because human eyes cannot see the problem until the damage is already done. By the time a farmer walks out into their field and sees a withered leaf, it's already too late. The disease has spread.
Section 1. The silent crop epidemic.
See, the enemy here is microscopic. We're talking about a tiny yellow spot on a single leaf. Maybe a super slight change in the texture of the plant, or a fungal infection that's literally invisible to the naked eye. We humans just aren't biologically equipped to process these tiny visual cues across hundreds of acres of farmland. By the time a farmer actually notices these seemingly minor physical changes, the infection has taken hold deeply within the plant, and the yield from that crop, it's already lost.
Section 2. How plants speak.
But what if I told you we could actually listen to what plants are saying long before they visibly start dying? It sounds wild, but plants actually do communicate stress incredibly early through microscopic, invisible signals. Way before a leaf turns brown, a diseased plant starts reflecting light differently. Its thermal signature, or temperature, subtly changes. Its internal pigment composition shifts, and its water content starts to fluctuate. The plant is broadcasting its illness. We just needed the right tools to decode the broadcast.
Enter artificial intelligence. Imagine being a farmer, sitting down for breakfast, and your smartphone buzzes with this exact alert. Possible fungal infection detected in Sector 4. Confidence level 96%. You get this notification before precious pesticides are wasted blindly spraying healthy crops, and most importantly, before the harvest is ruined. This isn't some futuristic concept from a sci-fi movie. This is happening right now. This is precision agriculture.
Section 3. Reactive to predictive farming.
This brings us to a massive evolutionary leap. You see, traditional agriculture has almost always been reactive. Farmers react to problems after they physically appear in the field. But AI completely changes the paradigm to predictive farming. Instead of reacting to a disastrous outbreak, algorithms predict the outbreak before a large-scale spread can even happen. It is literally the difference between treating an illness and preventing it entirely.
We're talking about building an intelligent ecosystem where deep learning models actively improve crop yields. This means automatically detecting diseases, optimizing exactly when and where to irrigate, and continuously monitoring fields using drones and satellites. And here's a huge point. By knowing exactly where the disease is, farmers can drastically reduce the amount of unnecessary pesticides they spray into our environment.
So how do we actually make this predictive farming a reality? Well, it relies on a really specific integration of cutting-edge hardware and software. On the hardware side, we have IoT sensors, RGB cameras, drones, and honestly, even just standard mobile phones. On the software side, we pair that with computer vision, deep learning, edge AI, which means the data is processed right there in the field without needing a constant internet connection, and multispectral imaging to see light wavelengths way beyond human vision. This specific tech stack is transforming rural economies by literally putting lab-level analysis right into a farmer's pocket. The complex supercomputing happens in the background, delivering simple, actionable insights to the person in the field.
Section 4. Why this matters globally. Let's zoom out for a second, because the stakes here are absolutely incredible. As our global population rapidly races toward 10 billion people, we simply cannot depend only on traditional methods to achieve these critical global goals. I mean, we're facing unprecedented challenges with climate change. We need to conserve massive amounts of water, reduce chemical pollution, and somehow ensure food security for a booming population. The old ways of farming simply aren't going to scale to meet these demands without destroying the planet in the process.
The bottom line is this. Giving humanity a fighting chance to grow more food with fewer resources requires artificial intelligence to act as superhuman eyes. We've basically reached the limits of human perception in agriculture. So to step into the future of sustainability, we absolutely must rely on intelligent systems to bridge the gap between what we need to grow and what our planet can actually sustain.
Section 5. Empowering the modern farmer.
But here's the catch. Building powerful algorithms is totally meaningless if the tech doesn't actually serve the human being at the center of it all. For this technology to actually work, it has to be democratized and tailored to the real-world conditions of the people working the land. AI diagnostics can't just be a luxury for massive corporate farms. It has to be affordable. It must be explainable so a farmer actually trusts it. It has to be accessible in local languages, and it must function in remote regions where internet connections might be, a bit spotty. It literally has to adapt to the dirt, the mud, and the reality of the field.
And that brings us to a quote that really anchors this entire explainer. The goal is not replacing farmers. The goal is empowering them. Look, there's often a lot of fear that AI is coming to take jobs, but in agriculture, AI is here to provide affordable, immediate diagnostics to support small farmers, not to take their place. It's a tool. It's much like a tractor or a plow, just vastly more intelligent.
We are entering an extraordinary era where autonomous drones scan fields, digital twins of farms simulate crop health before a single seed is even planted, and real-time sensors monitor the soil constantly. We're evolving agriculture from intuition-driven guesswork to data-driven intelligence. The farm of the future is literally a living data ecosystem, constantly learning and optimizing itself. As we wrap up this explainer, I want to leave you with a thought-provoking question about the true future of how we're going to feed the world. Will the next agricultural revolution be driven by heavier tractors and more fertilizers, or will it be driven by intelligence? The evidence strongly suggests it's the latter. Thank you so much for joining me to explore the digital harvest. I highly encourage you to keep an eye on how artificial intelligence continues to reshape the very roots of our global food supply.